Satish Kumar, working as an Associate Professor in Marine Engineering Department of Ahmed University. In that we will discuss about a fuel ammonia as a marine alternate fuel. So fuel is a material that carries energy in chemical form. Fuel substances when burned or when it is converted, it produces energy. So ammonia, which is the formula is NH3, is gaining attention as potential clean fuel in various sectors, including maritime industry. The detailed overview of ammonia as fuel, converting its production and its application in internal combustion engines, especially in marine industry, we will see, and its usage and its pros and cons of ammonia as a marine alternate fuel. The traditional production, it's by the Haber-Bosch process in energy intensive and primarily relies on natural gas. It's produced from natural gas, leading to significant CO2 emissions. So the green production will be from using renewable energy to produce hydrogen and can reduce the carbon. By using hydrogen, we can reduce the carbon footprint. But this current method is more expensive. So when the combustion during the ammonia produces nitrogen and water vapor, the NOx emissions can be managed with selective catalytic reduction, which is called SCR systems, or with the latest technologies. The zero carbon emission. If ammonia is produced using renewable energy sources, it can be nearly carbon neutral, though managing NOx emission remains a challenge. So for NOx emission, we have to use SCR or the latest technologies for reducing the NOx emissions. So the green ammonia is produced using the renewable energy sources and also by hydrogen, and then green ammonia is produced, which is stored and also used for fertilizer purpose and used for power generation in the land, as well as a marine fuel in the marine industries. So we have other way of producing ammonia will be the water is purified and water is split into hydrogen and oxygen using the electrolyzer by the electric current. Electrolyzer even can be powered by using solar or wind, the tidal energy. Hydrogen used as fuel locally converted into ammonia by the synthetic natural gas for transport purposes. Ammonia is shipped to places in the Southeast Asian countries, then reconverted to hydrogen and used as a fuel. So the applications in the internal combustion engines of maritime industry can be used with certain adaptation. So the engines has to be modified. The combustion characteristics, ammonia has a high auto ignition temperature and low flame speed, requiring modifications to the engine design to ensure efficient combustion. Fuel handling. Ammonia needs to be stored and handled under pressure or at low temperatures. Involves specialized tanks and safety measures due to its corrosive nature and potential health hazards. Current developments, prototype engines. Some companies and research institutes are still working on converting design engines specially for ammonia. This includes adjusting ignition systems, combustion chambers and fuels. Ammonia, the nitrogen can be taken from air, even the hydrogen can be taken from natural gases. So by the nitrogen and hydrogen by the volume 1:3 ratio by volume, then it is used with the ammonia synthesis process with the ion catalyst at 400 to 450 degrees centigrade. Then the gases are cooled, then you get the liquefied ammonia. So this is also a way of alternative methods for producing ammonium. So the advantages. The advantages of ammonia are it's carbon free. When produced using renewable energy sources, ammonia can be carbon free and it helps in the zero carbon to attain the zero carbon emission. Energy density. Ammonia has higher energy density by volume compared to hydrogen, making it easier to store and transport. Established infrastructure. Ammonia is already produced and transported globally for fertilizers. So it is in use. So the more it is to be potentially reducing the need for entirely new infrastructure. So accordingly, we have to improve the infrastructure. So the main disadvantage of ammonia will be the NOx emission. Ammonia combustion can produce NOx, which is a pollutant and needs to be managed with after treatment system. So energy intensive production. Traditional ammonia production is energy intensive and emits CO2, impacting its overall environmental benefits if not produced sustainably. Handling and safety. Ammonia is toxic and requires careful handling and storage. It can be corrosive and pose health risk, necessitating rigorous safety protocols. Engine adaptation. Significant modification to existing internal combustion engines are required to use ammonia effectively, which can be costly and technically challenging. Look at some of the key players, their plans for regarding the marine as alternate fuels. Many shipping companies like Maersk has been a leader in adopting the alternative fuels. They are investing heavily in research and development of green fuels like ammonia. The company has ordered vessels capable of running ammonia as zero emission fuel. Even V-Ships is adopting alternative fuels like ammonia to reduce emission and meet IMO regulations. Ammonia is also emerging as future zero carbon option, though still in early stage of adoption. So ammonia are being explored for the potential to provide zero emission solution. Ammonia can be used as fuel cells, and companies are investing in these fuels for their long-term sustainability. So thus the maritime industry is in a state of transition, with major shipping companies investing in a diverse array of alternative fuels to achieve greater environmental sustainability and regulatory compliance. Each company's approach reflects its strategic priorities and evolving landscape of marine fuel technologies. So thank you.